Alright, in this video we're going to learn about solubility and solutions. So a solution is made up of two parts. It's made of a solvent and a solute. The solvent is what does the dissolving, and the solute is what gets dispersed in the solvent. Water, we learned, was known as the universal solvent, and the reason why it's given that name is because it can dissolve ionic compounds as well as polar covalent compounds. The only thing water does not mix with is non-polar covalent compounds. So when we dissolve an ionic compound in water, we call it an electrolyte. And the reason is because it can conduct electricity when it's dissolved in water. So ionic compounds, remember that ions are charged particles. So when you dissolve an ionic compound in water, it dissociates into its ions. And if the ions flow from one place to another in the water, that's what electricity is. It's just the movement of charged particles. Now, when we dissolve covalent compounds into water, it is a non-electrolyte because covalent compounds are not charged particles and therefore they cannot conduct electricity. So, for example, if we were to dissolve carbon dioxide, a gas, or sugar, this would be an example of a non-electrolyte. So there's several things that we can do to increase the rate at which a solution is formed. One of those is by stirring. So if you increase the contact that the solute has with the solvent by mixing it around, it's going to increase the rate of the solution formation. Also, we learned in the last unit that kinetic energy is the energy of motion of the particles, and average kinetic energy determines what the temperature is. So if we heat up a substance, it causes the particles to move more quickly, and if they're moving more quickly, there's going to be more collisions between the solute and the solvent, and therefore the rate of solution formation will also increase. And we can also increase the surface area. So if we were to take a sugar cube versus granulated sugar, the granulated sugar would dissolve much quicker, and that's because it has a greater surface area. When it's crushed up, the surface area increases, and if there's more surface area, there's more contact between the solute and the solvent, and therefore the dissolving can occur more quickly. So the term solubility means the amount of solute that will dissolve into a certain amount of solvent. And it's different for different types of substances. So if we look at a gas versus a solid, temperature is going to affect the solubility of gases and solids differently. So if you were to put a Coke can out and it was open to the air and you left it in the warm air, it goes flat. And the reason why is that the solubility of gases decreases when the temperature increases. So there's going to be less dissolved gas the warmer that you are. However, solids act differently. If we were to heat up water, we could dissolve more sugar into that substance or into that solvent than we could if it was cooler. In the next video, we're going to take a look at solubility curves, and these curves help us to demonstrate and to look at how much solute can be dissolved in a solvent given a specific temperature.